Hey guys, and welcome to our final video of 7.3, and we have finally gotten to dividing rational expressions. Now, just as multiplying rational expressions is similar to multiplying fractions, dividing rational expressions is similar to dividing fractions. We simply multiply by the reciprocal. So if you don't remember if I had let's say I was taking 2 and I was dividing it by 1/4, I would write that as 2 times the reciprocal of 1/4, which is 4/1, and that would give me 8. We're going to do the same thing with rational expressions and then just end up multiplying like we did above. All right, here we go. Divide the rational expressions, identify any excluded values. Now, those excluded values, there's one extra piece that I'll tell you about with those when we're doing division. Okay, so I have x plus 7 quantity squared over x squared divided by x squared plus 9x plus 14 over x squared plus x minus 2. So what I'm going to do is I'm going to keep the first fraction as is, except for, because we need to factor, I'm going to write this out as x plus 7 times x plus 7, just in case I'll be able to cancel anything in the future. I'm also going to write x squared as x times x. Now, because we're dividing, we need to multiply by the reciprocal of the second one. So the reciprocal, now our denominator becomes our numerator and vice versa. So this is going to be x squared plus x minus 2 over x squared plus 9x plus 14. All right, now what we do is make sure everything is factored, similar to what we did above. X plus 7 times x plus 7. Now, x squared plus x minus 2, that factors to x plus 2 times x minus 1. In the denominator, I have x times x squared plus 9x plus 14, factors to x plus 2 times x plus 7. Now, before we move on, let's talk about excluded values. If you remember, excluded values come from what would make the values that would make the denominator equal 0. So we look at all the factors. In this first fraction, both the factors are x. So we know x cannot equal 0. Now, in the second fraction, remember that the denominator used to be x squared plus x minus 2. So because it started as the denominator, we actually have to think about excluded values from not only the new denominator, but also the numerator. So basically, the entire second fraction. So luckily, I have factored that down here. So I need to look at this one, this one, this one, and this one for my excluded values. So let's add on to my 0. That's going to be a -2, a +1, and a -7. All right, now let's cancel stuff we can. I've got x plus 2, and I've got an x plus 7, but that's all I can cancel. So my final answer is, in my numerator, x plus 7 times x minus 1 over, I'm just going to leave that back as x squared. And x cannot equal 0, -2, 1, and -7. All right, so basically the two differences between dividing. First, dividing is just multiplying by the reciprocal, the second fraction. And the excluded values come from both denominators and the numerator of the second fraction. So let's try B. 6x over 3x minus 30 divided by 9x squared minus 27x minus 36 over x squared minus 10x. So let's rewrite our first fraction factored out if we can. 6 we can write as 2 times 3, and then we also then have that x. The denominator, 3x minus 30, I can take out a 3, and that would leave me with x minus 10. Okay, now I'm going to flip my second fraction. So my numerator is going to be x squared minus 10x, and my denominator is going to be 9x squared minus 20 minus 36. All right, I'm going to have to hang out with that second fraction for a while to get all the factoring done. So if we look at the numerator here, x squared minus 10x, actually that one's not that bad. You're just going to take out an x. So let's rewrite the numerator down here. That'd be 2 times 3 times x. And then in this one, you can take out an x, and then you'd have left x minus 10. All right. in the denominator, we have 3 times x minus 10. But if we look at this trinomial, 9, 27, and 36 all have a common factor of 9. So if I take that 9 out, I'm going to write this next to it just so I don't have to do a whole nother line of work. If I take a 9 out of all those, divide each by 9, that's going to leave me with x squared minus 3x minus 4. Okay, and then I can factor this trinomial. That would be x minus 4 times x plus 1 with that 9 still in front. So that's going to be added to my denominator. Not added, but written in there as well. Okay, so this trinomial turned into those 3 factors. Okay, let's talk about excluded values. Remember, excluded values come from your entire denominator and anything that came from the numerator of your second fraction. So that would be this factor, and then every factor with an x in it in the denominator. Okay, so x cannot equal, from my numerator, the factor of x would give me 0, x minus 10 would give me positive 10. That's also the denominator, so I do not have to write that again. And then the factor x minus 4 gives me positive 4, and x plus 1 gives me negative 1. Let's cancel out common factors like x minus 10. Gosh, is that all? Oh no, I can cancel out 3. And I think that is it. So in my numerator, I am left with 2 times x, so that's going to be 2x squared. In my denominator, I'm left with 9 times x minus 4 times x plus 1. And there are my excluded values. Awesome. We will do the rest together, guys.